And okay, this video is recorded. Okay, I stop at restoration of this. Okay, before my computer restart, we're talking about sequence diagram, right? Sorry. The sequence diagram let me know how each method for each class is interact. But in this in the sequence diagram, it doesn't provide the detailed implementation of what should be in the code inside, but it's show what it show that how each part of the system interact and what is the input and output of those interaction. So this is example for a sequence diagram. It's a diagram that show the detailed interaction among object. And normally if you start with some kind of actor, but that is not the high level. Actually, this diagram will be some, it can be drawn from high level until low level. And if you check this diagram in detail, we have these actors call some method here for login. And this login method is called, then it's called to this process. And finally, after this execution of within this object, it will return something into this interface. But that is the detail. How about this one? If we have login action and we get the string, we send the data, but actually this is not the it's in some high level sequence diagram. And when the data is sent, but okay, when we release something like this, we have no idea what is the data. Can you guess? Maybe or maybe not. And then if you have to implement this, what happened? Can you implement what should be the data inside here? This one called get data from this login actor. And when the data is get checked to valid data, and then return some kind of message as a valid. But anyway, the people talk about the sequence diagram in many different. Actually, the diagram nowadays drawn in many different way, and further than that, just like this diagram, we have this. This is a sequence, but it's high level. It doesn't provide anything. Just like what method is called among this kind of object, but this is not it's maybe called uh, object or called component, and blah blah blah. We have a component reactor, we have website component, we have web server component, we have admin component and database component. But you can see that this is not, I don't know, it's not detailed enough. And if some people provide this to you, you can say that, okay, this is a sequence, but it's not fully correct. Okay, anyway, I give you this idea because I just want to remind you of what is the what is the what is the thing, the idea of component. Why? Because as I said, the component design, we need to what? We need to think, we need to make a plan how each component interact. And normally, if you get a good design, the way that component connect, we can retrieve it from if you get a good document, good team, we can retrieve some kind of component design and how each component or each method is interact through the sequence diagram. But in some team, in different implementation of software process model, just like test-driven, data-driven, they just code it first. They just create a test and create a code and run the test, run the code. And if the code is passed the test, I mean, it can be used, and they just write to the other diagram, to the other function, and that kind of thing is like it's a reverse, it's some kind of reverse process, and and then they come back to make a document or make a sequence again later after they implement some method. But there's no one fixing rules of what should be done in each software development. It depends on team, it depends on many factors. But anyway, if you are just an experienced software engineer, just when you graduated, just first year, second year, the thing is, when you need to construct, if you're working as a developer, as a dev team, and you need to construct some kind of software, and what should be, is it, if they give you some kind of user requirement spec, and you create the software, yes. But if they give you user requirement specification, system requirement specification, and also sequence diagram, then you can, with sequence diagram and user requirement spec, and system requirement spec, you can, it is better, it's clearer to to understand what you need to implement and what should be the return. That is why in the construction, the component design is also important, because any of this one, okay, just like this one. If they give you something like this, you can expect that we have 4 or 5 blocks of code that we need to develop, and this one we need to at least provide at least one calling, and this one we need to provide 1 or 2 operation for this method. So we can do some kind of high-level design for each component from the sequence diagram. And And to construct the software, yes, we need to. We not just construct. We need to design how each component interact, and not just component. We can. I give this presentation set the component. What is a component? What do you study from last semester? What is the idea of component in software development? Or any answer? What is the meaning of component? Sorry. You have no idea. The component is like, it's depend on how you call it, but for MVC, we have 3 components, just like model, view, and controller component, right? And actually, the idea of component here is like a working piece of software. Maybe it's a class, one class or one object, or many objects that interact with the other part of the software or interact with the other component. And then if we the suggested way of construct the software is to divide or separate the software as a component, just like what you studied is just like what MVC said. Model, controller, and view to represent part of work that is related to the implement to the goal focus of that part of software. And to implement the component, yes, we should have some kind of good class design. But for example, for MVC, we have some kind of, we can design the class corresponding to the model concept, and we can define the class corresponding to the controller concept, and we can define the working part of the object, which is represented by the view. So the most I should say that the most fundamental unit of programming in object-oriented programming, or just in object-oriented programming, just like when you use a Java or you use any programming language, the most fundamental unit is a variable, and the variable actually is instantiated from a class. That's it. Doesn't matter what kind of programming language you use. If even you use the script, JavaScript or Java or C or anything, when you declare the variable, it means you declare the type. Sorry, when you declare the variable, it means you declare the object, or you declare one thing is that allocate the memory and the functionality to use, and that is the most basic unit of programming. And then in Java or in object-oriented programming concept, we can define our own object, like, and by creating a class, and that is it. A class is something that we want to use it for our project. We define a class for using as an object in our software, and then to construct the software, It is better if you have a good class design. And yes, I think it's already explained in the class. We have we need to carefully choose how to use encapsulation, inheritance, polymorphic, polymorphism, and abstraction. And this slide gives you example which I already explained from last time. And we have talked about the coupling, and then what kind of coupling that we talk about. When we design a class, and when you look at this sequence, you may say that if a class has a high coupling, it means can it represent by this sequence diagram? I can say yes or no. It depends on the people who created this diagram, because some people may not may writing the class, the sequence diagram by directly interact among method and object. But some people, if they are detailed enough, they will provide when this kind of method is called. It's called to which interface, and which interface is implemented by which class. And if you get that kind of sequence, you are lucky that they provide detailed design for you. So and then that kind of design or document is made, it help you easier. It's make you easier to implement the code with good document design. But if not, okay, anyway, when you try to construct a software, you need a good design of object and of class and component and blah blah blah. That is theoretical things. And in this slide, we talk about what is a good class design for coupling. When we design class, we need to keep a coupling rules. What is coupling criteria? The first thing that you think about is the number of connection. If you have a large size of method that connect to the other object, other component, you have a list of high coupling. And if you expose every method outside, yes, you are going to provide the chance of high coupling to the other object. And flexibility, if you just fix your code with specific class, with some specific class and method and parameter, it means that you are you have a chance of getting high coupling output. And this is more detailed explanation of kind of coupling. We have simple data parameter coupling. What is it? The example is that if you have some kind of method, like this in the chat, public int add, we have int I and int j. You can say that this method has a high coupling with I and j because it needs input as an integer. This is high coupling. Yes, we specify only integer can be used in this method. But it is exception because we have this example is a data parameter coupling. We use primitive data type passed through the parameter list. This is fine because it's a primitive. It's the most fundamental data type that is used, and it will not be modified anymore. This is normal and acceptable. Simple object coupling, instantiate that object is okay. If you have some class and you want to instantiate some object inside that class, it's fine. Object parameter coupling, if you need the other object to pass as a parameter, just like this. If you have method like this, get total invoice, we pass customer in, we pass the order in. And then we need to extract some object from this. Is this good? It may be good or it may be not good. But why is good and not good? Can you give me some answer for this code? The code in the conversation, if it's good or not? Because now we passing object as a parameter, and we are encountering the object parameter coupling. Is it good or not? Give me the answer in the chat box. Okay, it may be not. Yes, I agree with this answer. Does this code working? Yes. Does this represent the business model well? It's okay because we want some output. Maybe we giving the customer, we giving the order, and we want the total bill of from the customer and order output. Yes, it's okay. But if there are some change in customer or the order class, we need to recheck whether it's compared this method still working or not. Right? That is it. The code work, yes, but when there are change in this class, the customer or the order class, it may not work anymore. It depends on implementation and you need to, but a good class design, a good component design should notice this and try to avoid this. And you have semantic coupling, coupling which change something other than itself. And the example is that if you change some kind of what is this? The coupling which change something other than itself. What does it mean? And have you ever experienced this? No? Okay. It's some kind of if it if you implement 2 or 3 methods together and some things is changed in from the other method, it will also affect this one. But okay, I think let's see if we going to already encounter this again in the software testing period, and that in the software testing, if it's cannot identify something like this, there will be a lot. There will be high possibility of getting the error after even the test is passed. And this kind of cupping can also make the makes pass the test but fail in the deployment phase. Okay, let's see. We may come back to this again when we decide the test case. And to make it, and I want to show you that when this thing happen, you need to be careful when you design and implement the code, because sometimes the code can pass the test in some criteria, but when they run, when they on the deployment, they have different input, different operation, and some kind of this thing can cause a problem. Okay, anyway, let's go. I think we need to finish this presentation today. Okay. Next, what is good card? What should be the good card design? Yes, common design pattern. Still remember what is the design pattern that you studied last semester? You can follow. So you can get a good class design by following the design pattern, because it's every pattern has a definition, and if you implement that, if you implement your design, follow that design pattern, it means it will help you reduce complexity by providing ready-made abstraction, reduce error by substitutionalizing details of common solution. You provide suggestive design alternative, and patterns streamline communication by moving the design dialogue to the higher level. Okay, what is it? Just like the page pattern, they just provide more flexibility for the interface and separate it from implementation. About the other pattern, proxy, observer, and blah blah blah. Uh, that is the point. If you have no idea now why we need to study design pattern from last semester, actually it's because you need to understand the pattern, and you need to see the code with the pattern and combine with the code without the pattern. This is work. Both of it can work. But if there are something that needs to be changed during or after the implementation phase, for example, the most classic thing that's happened is customer want a change. They have a change requirement, and the system needs to be changed. The unstructured unstructured and bad design code will not be able to sustain this kind of change. But the working code with a good design, it has higher potential to adapt according to the change. And to adapt that, we need to provide the idea of structural design. Sorry, but I have to say that clear. Architectural structural design of how each component interact, how each class, each object interact by providing abstraction, the proper abstraction. In what? We need to provide the proper abstraction of design, of structural architectural design, or any kind of design. Provide the abstraction by follow the design pattern. It's easy to say this, but if you follow this, if you understand it and you are able to follow this, you will get the idea of what should be good in implementation, in implement of the code. And that is good practice for software construction. Not just create a code that work, create a code that is work with the design that is ready for possibility of change. Any example? The classic implementation of design pattern that is used in the MVC. Still remember this? What is it? What is it? Anyone here? Dependency injection. What is it? We provide the interface inside the argument of the method. In order that we can inject the interface, we can inject the component that implement those interface instead of inject tightly bound component instead, right? And also inversion of control. Sorry, typo. You studied this from last semester, and by implement the DI and IOC pattern or framework, you are able to switch different repository, right? And that is a kind of practice that the good practice, and that people try to implement that as a framework or as a pattern to follow. And okay, that is an example. What is a good car design? By implementing the design pattern, will help you make your software more flexible and sustainable for the change, and easier for test. And I will explain again why it is easier for test. And we need to aim for a strong cohesion. All part of the class support central purpose. What does this mean? Yes, all part of the class support. Central purpose of the class. It's common philosophy that if you create a customer, all the data, the attribute, the functionality should support the operation of the customer object, right? How about the inventory? Should we add the inventory into the customer? We should not, because if we add that, if we make the customer and the inventory inside the customer, it's not support the purpose of customer object. Right, we need to implement something that support the inventory object also. But and when we put some two of this in the same object, it will represent the multi-purpose class, and that is not good, and that is not high cohesion object, which is not proper for asset. It's not proper to use. And easier for what is this class for? For example, if normally when I develop a system, I create these two types, student and students. Why? Why create something like this? You have any idea? Yes, yes, correct. Like this answer, because the student object, the first one, represent one student, and the students with S represent operation information that is related to many students or a group of students. And by this, it means that the student object here will represent what operation and attribute related to one student, and then we can create the operation or function method, which is represent many students. That is the idea, and this is the idea and limits and the explanation of what should be for design for the high cohesion. And then to build hierarchy, tier of have to build the connection and the level of the class. Just like we have one student, and the other level will be the students, and maybe after students we have a course or class that student enroll or something like that. It will be in a hierarchy, and we can manage complex sets of information by separating into multi-level, just like this example. If I add this one, we have many students, and to make many student operation more clear, we have a class and something like this. The course object maybe contain the class and there's many students, and how this operating continue. That is the idea. And this is the definition I give you of what is high cohesion, low coupling, and high coupling. And I recommend that you read this. And okay, what is single responsibility principle? from design class, just like what I said. The class must be responsible for itself. Role cohesion is when you break the SRP and have multiple responsibility in your class. Like this, high cohesion is a logically class contain behavior or method and state of with variable to make its own unit as its own. That is what I already explained. Give example, and this is some conclusion that yes, this is a good conclusion for what should be high cohesion, low coupling, and high coupling. But what this the number of cohesion and coupling is not well defined. It's dependent. It's a qualitative term and it cannot measure directly. So that is why we need to create some kind of standardized way of measuring this qualitative thing and measure the quality of the code, measuring the quality of design document or anything else, blah, blah, blah. That is the other big subject when studying this as a software metric for measurement, the metric for evaluated software. And okay, that is the other part of the subject, the other course. And I think if some of you already study with Ajahn Paskon, that he is teaching that course in detail of how we can measure and evaluate the quality of software. What should be the proper metric for implement for use to evaluate the proper software. And what is a good design? Is it design for a test? What is this? What is the meaning of design for a test? The meaning is that I don't know whether have you ever doing some kind of the front end, and this is the example code for C# programming language. That okay, it doesn't matter what programming language it is, but this one, what the code does is open the connection to database, and then create a command to select the data from the specific username from this text in the label on in the graphic user interface. And when this execute, just put the deleted data into the label 1, label 2, and label 3. Does this code work? It's working is a standard coding example that exists for the beginner, for just like I don't know, a lot of code example from Stack Overflow, from many books. Give example like this. My question is it a good design, or it's just implemented code that is working and can be used as example? From my point of view, it's just an example code. It's working. Is it work? Yes. But what should be the problem from this code? The first problem, if database is changed. If they change this from username to user ID instead, what happened? This method, this button object, this method inside the button object will not work anymore. Okay, that is the first thing. And then if there is no input here, what going to happen? I don't know. And if this data, if this is now data, or if any of this is now, what happened? We don't know. Can this code work? It's working in some specific condition with the specific database that they design here with the specific data type and data availability of this method. And what happened if this data leading, if this is crashed, this method will crash and they will maybe show nothing or give the error or blah blah blah. And then can you expect, can you predict how long this program will work? How many hours this program will work? You have no idea. It may work as soon as far as there is no change in any of these. And you need to expect that the data in the database in this table are available for and is available and selectable from this command. Is it good? Is it work? Is it fast for use? Yes. But if there's something changed, we have no idea. And that is what is different between working code and well-designed working code. We need to separate this. What should we do? What we should do, we can insert it repository object or add the dependency injection into this method. So whenever this method is called, we can give a specific implementation of data part of a data repository, which is working and testing by the other process. And then we just receive the data, we just call the already tested method that is working and get some kind of we create the list, create the object for summary object to show. And this should be coding as whatever or something like this. To provide better understanding of the code, better component, better construction construction code, which is good, easier for test in separated tasks. And when we come back to this idea again, to this example code again, when we talk about testing. And this one example is the user interface and business rules are putting together in one method, which is working, but it's not well designed. And then what else when we construct a software that we should concern? Further than good design, good component design, good car design, we need to create the testability. Testability, what is it? It's a link between or among the product. It's linked among different level of abstraction or the same level of abstraction. And testability in the software to provide maybe we can start from product requirement. We can back to stakeholder relational and forward to design code and test case. So what this is, it means that in the software construction or any software development project, there are some important document, some important artifact. What is the meaning of artifact? Just like the output document or the output of the process or whatever the remaining of the process. And that is some people we can think about it as a document. Okay, what does this mean? This means that this kind of product, this kind of testability is so important. So what is it and how about this? We can use an icon as a testability. It's like, okay, we have the item from A to G, and we can draw how the A is related to the B, and how the B is related to the F, and G is the process that, okay, from A to B to F to G, and then from A to C to F to G, and then blah, blah, blah. Just like the question of this kind of drawing as an icon is, okay, if we are at C now, what next should we go? And where we can trace back if we are at C now. It means that okay, from this diagram we get from A to C, and then from in some condition we have link from C to D to E and to G, and something like this. That is like we can trace, okay, if we are at G, what is the process, what is the step before, what is related to the G? We can see it from here that the F is related to the G and E is related and communicated with the G. But what is it? It's some kind of idea, some kind of representation that represent the link among the product on different level or the same level. But in the icon presentation, you may have no idea, but this one. This example create a unit direction matrix. As an example, is this? It's a matrix that represents the software product in each part. just like for the requirement that, okay, the first one, the first row, restaurant has 2 ordering station. From this requirement, corresponding to the functional design as management scheme number 2 and internal design on document page 45. And you can find this implementation in the course line 12,485. And this is for this requirement, it has been tested on test number 34, 57, and 63. Might provide this kind of matrix. You can trace that, okay, if we can find that, okay, if this function is finished, it means that test number 43, 57, and 63 is passed. And the code from design is work. And if there's something happen in this function, if we want to look at the code, which line we have to go to? Which line we have to go to? If you have some problem in order screen, which line of code we need to go to? You can find out from this testability metric, right? Which test we should check? Okay, we can go in to check with this test. This is some unique direction metric that provide, okay, from this requirement, if something happen, we can check from the internal design, we can check for functional design, code, and the test. By providing this kind of document, this is what is make your work more complete. And if somebody, the other teams or the other people want to what? If they need to continue on your working or change or need to working or work continue whatever it is. If they look at this document, at this testability, this testability will provide the proper understanding and the fast way of understanding what should they're looking for inside your project. And it's important for the constructional because you can check, okay, how many tests is finished, how many line of code is finished, how many function is covered, and blah, 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 blah. So this metric represents the relationship among requirement, functional design, internal design, code, and test. How many tests related to this requirement? Where the code related to this requirement is in, and blah, blah, blah. So you can have a high-level visualization of what is inside your constructed software. Okay, just like this, we have some unique bidirectional testability metric, just like we have a communication core GUI, and for the class that is related to the communication, what should be FR functional requirement? What should be the setting template? How it's related? Test city, test point, blah, blah, blah. And that is the way it is. The things is you need to provide the testability metric for, sorry, you need to provide testability metric that the other people be able to trace, to understand how is your work. And benefit of this is that it can improve the impact of analysis. You can test back code. We can provide the selection test, regression test, and we can check whether which part of the code corresponding to which part of the requirement in test, and we can get a better idea, understanding of the change management. So we can have a plan. When the change is happen, what are we going to do with? And we can starting from the testability metric. Okay, any question now? Okay, if not, I will stop presentation, and that should be all for today. Okay, I'm going to stop recording.